Alright, so for the first part of this review is talking all about piecewise functions. So when you're doing this part of the test, it will be multiple choice, but a couple things we need to remember is when you have an open circle for your domains and your inequalities, you're not going to have a line underneath. So if it's an open circle, it'll be a greater than or a less than. If you have a closed-in circle, then you're going to have an equal to be a part of your domain or your inequalities when you're writing your equations. So on graph number 1, I can tell that I'm going to start right here at positive 1, and I've got a closed circle on positive 1, and it's going to the left. So I need to know what the equation of this horizontal line is. Well, this horizontal line is touching at 1, 2, negative 3, and I'm going to the left of positive 1. As I look through my answer bank up here, there's only one that happens to match. So the equation I want is negative 3, comma, x is less than or equal to 1. Again, we're using the equal to because it's closed, and it's going to the left because my line is going to the left. The second line right here, it has an open circle at the 1, and it's going to the right. So I'm looking for an open circle to the right. It says right here that my slope is 2 and my y-intercept is 1. So let's see, from this point, if I go up to right 1, up to right 1. So that is the correct slope. So these are the equations that match this graph. For the domain, every time you think domain, I want you to think left to right. You'll notice from 1, I go left forever. And then up here, it looks like I have an open circle at the 1, but I'm actually using the 1 down here. So we're going from the left forever, and we're actually going to the right forever. So your domain is all real numbers. When you do your range, you're always going to go from the bottom of your graph to the top of your graph. So the first y value that I actually see that I'm using is negative 3. And then I have a huge hole in the graph. So I'm going to use negative 3. That's why I've got brackets. Union. I jump all the way up to 1, 2, 3, positive 3, but it's an open circle, so in a parentheses, and then I go off to infinity. The last thing I have to answer about this graph are any intercepts, so anywhere it touches the x or the y. It doesn't seem to touch the x at all. This piece doesn't touch the y, but this piece does at 0, negative 3. Okay, let's go look at our second graph. So for our second graph, because there's no open circle right here, I can assume that there's a closed one at 0. So that means I need something that's got a 0 in the inequality for both equations. So that has a 0, but not for both. No, 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 no. Oh, it must be this one. So you'll notice that it says I have an equation of a negative x and an equation of a positive x. So this is my positive x, because I'm going up, right one, up, one, right one, up, one, right one. And this would be my negative x, so I'm going down 1, left 1, down 1, down 1, right 1, down 1, right 1, down 1, right 1. So these are the equations that match. I have a negative 1x, and I'm using all the x's that are less than 0. And I have a positive x, and I'm using all the x's that are greater than or equal to 0. Your domain is going to go from the left to the right, and again, I'm going left infinity, right infinity. That's going to give me my all real numbers again. My range is going to go from the bottom of the graph to the top of the graph. I'm actually using the 0 because it got filled in on the second equation. So I'm going from 0 to infinity. I want anywhere it touches the x or the y, it touches them both at 0, 0. Okay, graph 3. So on graph 3, I have another horizontal line. It's at 1, 2, 3, 4, 5. So I have a horizontal line at 5. So I'm going to go ahead and see if I can find if any of these have a horizontal line at 5. Remember, a horizontal line won't have an x in it, so that's a horizontal line at negative 1, but I want 5. I've already used this one. Up here it is right here. I have a horizontal line at 5, and it says I'm going to have an open circle on negative 3, and I'm going to shade left. Well, that matches. So that's what I'm going to put right here. I've got a horizontal line at 5. And I'm using all the x's to the left of negative 3, open circle. The second equation that goes with it is x minus 3. And I'm going to have a closed circle and all the x's to the right. So x minus 3. And then I'm going to have all the x's to the right of negative 3. So I've got a closed dot and I've got a positive slope of 1x, so up 1, right 1, up 1, right 1, up 1, right 1, and it actually does touch at -3, my y-intercept. All right, when we do the domain for this one, I'm going for the left forever, and I'm covering up right here at the -3, and I'm also going to the right forever. So again, it's all real numbers. Your range is going to go from the bottom of your graph to the top of your graph. The lowest point down here is 1, 2, 3, 4, 5, 6. Double check. 1, 2, 3, 4, 5, 6. So it looks like it's -6, and then it goes off to infinity. And I know some of y'all are going, oh, but there's a hole right there. But remember, this is going to go off forever, so I'm going to end up covering it up. Intercepts are anywhere it touches the x or the y. So I have an y-intercept, and it looks like I have an x-intercept. So the y-intercept is at 0, -3, and 1, 2, 3. My x-intercept is at 3, 0. Number 4, I have another horizontal line. This time my horizontal line is at 1, 2, 3, 4. So I'm looking through all my equations for a horizontal line at 4. I've already used this equation, I've used this equation, I've used this one. Hey, here's a horizontal line at 4. And it says I'm going to have a closed circle at 2. Let's go see if that matches. Do I have a closed circle at 2 going to the right? Yes, I do. So that's the one that matches. So I have -x -3, where x is less than 0. And the second equation was y equals 4, x is greater than or equal to 2. Okay, so this is my 4 equation. This right here is my -x equation. Notice I'm going down 1, right 1, down 1, right 1, and I'm touching the x down here at -3 with an open circle. So when I do the domain, it's going to be different for the first time. I am going to go to the left forever from 0. But I'm not using 0, so it's going to go from -infinity to 0, union, and I never use the 1, but I do use the 2, and it's a closed circle at the 2, so bracket off to positive infinity. So that's the only domain that's had a hole so far where we're not using this piece of the graph. My range is going to go from the bottom to the top, so 1, 2, 3, but I'm not using the 3, so from -3 off to infinity, my y-intercept and my x-intercept. So it looks like I'm touching at 1, 2, 3, but it's an open circle, so I'm not going to include it. 1, 2, 3, but I am touching at -3, 0. That's my x-intercept. Okay, the last part on the front, my last graph, I see a u. And that means I need an x squared equation. So as I look up here, there is only one set of equations that has an x squared, and it's this one right here. So I'm going to go copy all 3 of these into the blanks that say equations. So it says I'm going to have a horizontal line at -1, and I do. And it says it's going to go where x is less than 2, open circle, and I do. It says I'm going to have a parabola shape. It goes from the worksheet up here says 2 to 2. That should be -2 to 2. That's a little typo there. So if you're watching the video, you catch the typos. And it says they're both going to be closed circles, because these both have lines, and they're both closed circles. And the last equation is your y equals x line, where x is greater than 2. So there's an open circle on 2, and it goes up and to the right. Okay, so now we're going to go write our domain. So I go to the left forever because I end up covering up this hole, and then I go to the right forever. So my domain is all real numbers. From the bottom to the top. Okay, so my lowest y value is -1, and some of y'all are going to say, hey, there's an open circle there, but I'm using it right here. So I am using -1, and then I jump up to the 0 because there's a space in between here. So union, 0 off to infinity. The only place this one touches the x and y axis is right here at the origin, 0, 0. Okay. All right, on the back, we've got one more graph to go with this table, and there's only one equation that I haven't used yet. So the only equation I have not used yet is this one right here. So 3x minus 1, where x is less than or equal to 1, and -1/2 x minus 1, where x is greater than 1. So this right here is my 3x minus 1, and this right here is my negative 1/2 x minus 1 line. So my domain, we end up covering up that hole right there, is all real numbers. Your range is going to go from the bottom to the top. Since I have arrows going down, I'm going from negative infinity all the way up to 1 with a bracket at the 1. Where do I touch the graph? It looks like I touch the graph at 0, negative 1, and it looks like I'm about a half. So I'm going to put 1/2 comma 0. You shouldn't have any fraction ones though on your test when it comes to intercepts. Alright, so this first part of the video was all about piecewise functions. The second part of the video is going to talk all about transformations. So the acronym I told you to try to remember was I, HOD, and over. So let's review what those mean. IHOD stands for if there's a number inside the parentheses, we're going to do a horizontal shift or stretch. We're going to do the opposite of what it says, and it's going to change the domains. If there's a number outside the parentheses, there's going to be a vertical shift or stretch. It's going to do exactly what it says, and it's going to affect the range. All right. So when you're doing these on your test, you need to know what the parent functions look like, and you need to know what the shifts. So because I have an x squared right here, I know that my graph is going to look like a parabola. And I know that this negative on the outside is going to reflect it over the x. I know this plus 2 is going to make me go left 2 because I'm going to do the opposite. And that minus 4 is going to make it go down 4. So I'm looking for a parabola that went left 2, down 4, and reflected over the x. So I normally start a parabola at 0, 0, but I'm going to go left 2, down 4. That's my new vertex. And I'm not going to open up because I'm going to reflect over the x. It's going to open down. The next parent function is the square root one. The square root one looks like this. And this plus 3 is outside, so I'm simply going to go up 3. It's the only change that happens. So normally it starts at 0, 0, but I'm going to start at 0, 3, and it's going to curve like that up. This parent function is my absolute values. My absolute value is the one that looks like the V. The plus 4 is inside, so again we're going to do the opposite. It's going to go left 4. Absolute value usually starts at 0, 0, but this one's going to start at negative 4, 0, and then look like the parent function. All right, on 4, 5, and 6, I give you the graph, and I want you to write the equations. So looking at this, you should be thinking cube, but normally the cube function goes like this. And notice it did the opposite. So this is reflect over the x. So f of x, if it reflects over the x, the negative is outside, x to the third. And down here I'm going to write reflect over the x. This is my absolute value graph. So I know I'm going to have an absolute value. You can tell the absolute value normally starts at 0, 0, and it looks like I went left 1 and up 2 from where I would normally be. So because I went left inside the absolute value, I'm going to put the opposite and put plus 1, and I went up, so I'm going to put plus 2. This is a picture of my square root function. And I can tell that I normally start at 0, 0, but I went 1, 2, 3, 4. I went left 4. So again, because I went left, it's going to go inside the symbol. And because I went left 4, I put plus 4. Okay. The last page of transformations, I gave you the description, and then I asked you to write the equation and do the graph. So this tells me I'm going to do a square root, and it tells me I'm going to go left 4, so inside I'm going to have a plus, I'm going to do the opposite, and I'm going to go down 2, so outside I'm going to have a minus 2. So I'm going to go left 4, 1, 2, 3, 4, down 2, and I'm going to draw my curve. This one's saying that my parent function is my absolute value, and I'm going to go left 2 and up 3. Again, if it's left, it's going to be inside, and you do the opposite. Since it says left, I put a plus, and then I'm going to put a plus 3 outside because that's my up, down. I'm going to go left 2 up 3, and then draw my absolute value shape. The last one on transformations, it tells me it's a square, which I know is a parabola. And it tells me that I'm going to go left 1, so inside I put a +1, put your squared on the outside, and then I'm going to go up 4, the +4 goes outside. So I'm going to go left 1, up 4, to put my vertex, and this time the parabola opens up. Alright, the last part of the video is the word problem part of the video. And I'm going to use scratch paper as I do this, just so that I have room to show stuff. So remember, I'm going to give you all the formulas. You don't have to memorize anything. When you're doing the word problems, you're going to start with the value. So they tell me the volume is 12. So that's the first equation I write. So volume is W squared H equals 12. And then you're going to write down the equation that they want you to look for. They want you to look for surface area, and this one has a top. So that equation would be area equals 2W squared plus 4WH. And then lastly, you have to figure out what variable do I want to have in the end. And they tell me right here I want it to all say W. That means the W stays, but the H is going to have to go. So now that I know it's going to go, I come over here and I'm going to solve for H. This says W squared times H. The opposite of multiplication is division. So H is going to equal 12 divided by W squared. And that's what I'm going to go put right in here. So in this parentheses, I'm going to go put what we just got right here. 12 over W squared. The other thing I noticed when y'all are doing these, you're forgetting to put this over 1. So the 2W squared just comes down the way it is. And I'm going to go ahead and simplify at the end, because when I simplify early, I seem to confuse some of y'all. So right now I'm going to go multiply top times top, bottom times bottom. So top times top, I get 48W. Bottom times bottom, I get W squared. Now just with this fraction, I'm not looking at this piece. I can see that I've got W's on top and W's on bottom, so I can simplify. I have more on bottom, so my final answer is going to be 48 over 1W. So I have 2W squared plus 48 over W. All right, so that's number 1 in the application problems. All right, the next one's number 2. So number 2 in the application problems. It says a box with a square base and no top has a surface area of 22. Again, I'm going to start with the one where they gave me the value. So they're telling me that the surface area with no top, so W squared plus 4WH equals 22. That's my first equation. That's what they gave me the value for. Then I'm going to write down what they want at the end. They want volume, which is W squared H. But they want volume with just W's. So the W can stay, but the H I put parentheses. Now I have to come over here to this first equation and solve for H. So the first thing I'm going to do is I'm going to subtract W squared. Okay. Now that says 4 times W times H. So now I'm going to divide to undo. And I'm going to take this right here, and I'm going to go plug it in right there. So in this parenthesis right there, I'm going to put 22 minus W squared over 4W. All right, now again, put this over 1. Let's simplify at the end. So I'm going to distribute. I get 22W squared minus W to the 4th all over bottom times bottom is going to give me 4W. Now, as I look at all 3 terms, they all have a W. So I'm going to take 1 W out of all. So 22W to the 1st, I'm going to take 1 away, minus W to the 3rd, I took 1 away, all over 4 because I took 1 away. That's my final answer. Okay, let's go look at number 3. So number 3 was one that we did as a warm-up the other day in class. I said, hey, write this in your notes. It says there is a wire that's 24 meters long, and it's going to be shaped into a square. So what's special about a square? We said yesterday all the sides are the same. So if I take 24 and I divide it up evenly, every one of these sides is equal to 6x. And they want me to find the area. Area equals the length times the width. So area equals 36x squared. And you're done. That one's easy. All right, number 4. On number 4, it says a pile of salt is in the shape of a cone with a diameter that's twice the height. Express the volume V of salt as a function of height. And then they tell you the volume of a cone. Well, this one, they give you information a little bit differently. They tell you that the diameter is twice the height. And they tell you the volume is equal to 1/3 pi r squared h. And for the first time, they asked me to leave the h's in. That means the h is going to stay and the r is going to go. And this is going to be the first time this has ever happened. No big deal. So I need to figure out what r is. Well, I know the diameter is twice the height. So we also know the diameter and the radius is half of it. That means the radius is equal to just the height. So in place of r, I'm going to go put h. So the volume equals 1/3 pi h squared times h is h to the third. And there you go. All right, on 5 through 8, it's the exact same thing again. It's just another set of practice problems. So let's see how far I can get before the bell rings. So on number 5, a box with a square base has a surface area including the top of 10. Again, we're going to start with the value. So they gave me the surface area of a top. So 2w squared plus 4wh equals 10. And they want the volume. And they want the volume in terms of only w. So I'm going to put parentheses where the h is, which means I have to come over here and solve for h. So I'm going to subtract 2w squared first. And then I'm going to divide by 4w. Now, once I did that, I can now see that 10, 2, and 4 are all even, so they're all divisible by 2. So I'm going to go reduce this to 5 minus w squared over 2w. So this is my h. This is what's going to go right here. Okay, and I'm going to put this over 1. I'm going to distribute across the top and simplify at the end this time, but y'all seem to do better when I do that. So 5w squared minus w to the 4th, so I distributed right here, and then bottom times bottom is 2w. Now they all have a w, so 1 can come out of all of them. So I have 5w, one of those went away, minus w to the 3rd, one of those went away, all over 2. Okay, let's go look at number 6. So number 6, it says we have a box with a square base and no top has a volume. So this time they're giving me the volume. So w squared h equals 6. And they want the surface area and it has no top. So area equals w squared plus 4wh. And they tell me that I only want to have w's again. So area equals w squared plus 4w parentheses. All right, so this is when I say, okay, let's go solve this equation for the h. This is w squared times h, so I'm going to divide, not subtract. And this right here is what's going to go over here. 6 over w squared. I'm going to remember to put this over 1. I'm going to bring down my w squared. Top times top, it's going to give me 24w. Bottom times bottom is w squared. I'm going to bring down my w squared, and I'm going to look just at this fraction. There's a w on top and there's a w on bottom, so I can reduce and get 24 over w. Okay, let's go look at number 7. So on number 7, we've got a wire that's 48x, and they want to shape it into a square again. So I take 48 and I divide it up evenly. So they're all 12x. They want me to find the area. So again, we're going to have area equals length times width. 12 times 12, I hope you know, is 144. And x times x is x squared. All right, so we have one more left. Let me get this done before the bell rings. A pile of sand in the shape of a cone with a diameter. Okay, so this time the diameter is 4 times the height, which means the radius is twice the height. Because remember, the radius is half the diameter. Okay, and then they tell me that they want me to write the volume of the cone in terms of h. So this time I want to keep the h and I have to get rid of the r. So I know that r is equal to twice h. So 2h goes in here. So volume equals 1/3 pi. 2 squared is 4. H squared is h squared. And I bring down my h. And then I have to multiply 1/3 times 4. So I'm just going to put the 4 over 1. And I'm going to do top times top. Bottom times bottom. Bring down my pi. And h squared times h is h to the 3rd. All right, so between all your homeworks and what we did in class and the review, I feel like you should be ready for your test. Study hard, Wildcats.